Hello, I'm Karthik. I'm the co-founder of Babbage Insight, where we are looking to build a AI data analyst. Why AI data analyst, what we are building, etc. I'll come to. Just a sort of a clarification or a sort of what do they call it? Not confession. What is that? What is that word for something that you say in the beginning, saying that disclaimer? Is that we are still in very early stages of building and we are talking, I'm going to talk about what we are building, how we are building and so on, but we have some solid ideas in terms of how we can actually use LLMs to build a actual AI data analyst, right? Uh, so why do we need an AI data analyst? So first of all, I think I don't need to explain to this audience, like the availability of data within companies and outside has like really exploded over the last, 10, 15, 20 years. And so now all decision makers are expected to use data for all their decisions. And so because of that, what's happened is like, if you're a manager in a company, you effectively have two jobs now. One job is to actually run your business. The second job is to interpret the data. And interpreting the data is not core to your business. And so what do? The company will have an analytics team. So whenever you need some data interpretation, when you need something from data, you go to that team and ask them questions. And they very quickly get swamped with what we think is necessary but repetitive work. So for example, my last job before this, I was heading data for Delivery, which is one of India's largest logistics companies. There we used to have a whole bunch of weekly and monthly business reviews. After each of those reviews, I would get some requests saying, Karthik, why did the trucking cost go up by 10% last week, even though the volumes didn't go up? Or for example, something like, why is it taking much longer to deliver packages in West Bengal? And my team would have to dig into the data. Each time it would be a different question, but a sort of a similar pattern to the question. And we would have to dig into the data, drop everything else that we are doing, and do this. So it was repetitive work because, as in, it was similar questions, but though not the same questions. But it was highly necessary work because these used to be largely questions coming straight from the CEO and so on. And so the hypothesis with which we are building here is like, why not free the data analysts of sort of repetitive, of the repetitive but necessary work so that they can actually work on what they have been hired to work on. I'm sure most of you would have come across copilots. Everybody and their uncle is building a data analytics copilot now. Why we are not building that? First of all, it's a sort of the metaphorical faster horse rather than a car. There's too much need for prompt engineering. If business people over the last 20 years have refused to learn to use Power BI, there's absolutely no chance they'll learn to use prompt engineering so that they can get the right output of the LLMs. And the last one is that, I mean, of course, all of us know that LLMs can hallucinate, and so you need to verify the answer. If you know the answer, then it's great to verify, but then if you don't already have context, then you don't know how to verify, and so it's a bit of a problem. So that's why we've decided to not go the copilot route, because if you think about it, if you have a true AI data analyst, it can go through much orders of magnitude of higher numbers of hypotheses than let's say what an analyst with a copilot can do. So which is why we are looking for a step change in terms of the productivity of the of analysts, and also like in terms of provision of insights to business decision makers. Okay, so first of all, let me put this out here. LLMs cannot analyze data. So all of us think that LLMs can analyze data. We have all possibly uploaded data sets to LLMs and said like, analyze this data, and we'll be fantastically wowed by how nicely it's analyzed. But the LLM is itself not analyzing data, because LLM is a text-to-text kind of a interpreter. The only way an LLM can analyze data is by writing code. And so some of the relative old-timers will know that what is now called advanced data analysis in ChatGPT used to be called code interpreter, because it used to write code and then execute that code and then like generate insights based on that. But then like what they quickly realized is that most people were using it for data analysis, and so they very nicely rebranded it to advanced data analysis. But still everybody is starting a company which uses LLMs to analyze data. This is 4 people sent me this tweet on the day it came out. But then I asked ChatGPT itself. I was like, why ask some third parties? Let me ask the first party. Can I tune an LLM to get insights from a time series, which is again what we are building as part of the AI data analyst? It says, no, don't do it. Because it is not great at pattern recognitions in raw data, but they're great at text generation. So why don't you just describe the data in terms of the mean, median, mode, summaries of the patterns and hypotheses, and then I will tell you what the insight is. Now, if I, as the prompter, have to give the LLM mean, median, mode, summaries, hypotheses, everything, what is the LLM really doing there? So in that sense, it's not a great data analyst. So I think that's one thing for us to remember. The other thing is that LLMs, the reason why we sort of don't evaluate LLMs well is that they can massively surprise us, both positively and negatively. Sometimes we look at the work that they do and we think it's absolutely fantastic. And at other times it's like, and so we think they are like really great machines. At other times we think they are like, they do very average work. So to take an example, like recently last month, the Indian election results came out, and some of you might know that I dabble in election data analysis. I used to write a column related to this for Mint about 10 years ago. So I uploaded the recent election data and said, analyze the data. It quickly sort of did some analysis, but then look at this analysis, it looked at total vote percentage per party. 19,000%, 11,000%, and so on. How do you think it came up with that? How do you think it calculated this as the total? This is data from the Election Commission website. Basically, the data set has a column called vote percentage. So across each constituency, it has taken the vote percentage and added it up without realizing that it doesn't need to, that's not how it's done. Then I asked it who won the most seats. It said BJP with 441. And I asked it for how it did that. It gave some result. I'm not going to go deep into this now. And then I had to say, think about the logic of Indian elections and calculate again. Now it realized that like we follow the first part is a post system, and then like it came up with a fairly accurate answer. Is 239 rather than 240 is because BJP won one seat uncontested. Then I asked something about this thing, what do you call it, alliances and stuff. It quickly guessed that there's NDA and UPA. And this is one more thing we need to remember about LLMs. The LLMs, their training data pretty much is what is there on the internet, which means that sometimes they may not, the data from a decade ago may not be much worse than data from a month ago. And so they'll have a lot of outdated data. It can make, this is relevant for generating code as well. I'll come to that in a little bit. And then whatever it did that, then I said, there's one bit I want to show. I said, who are the people who won by the narrowest margins? That was the question I asked. It said, here are the constituencies where NDA beat India by narrowest margins. Look at the narrow margin here. A negative million votes. Because what it basically did was to sort by margin, where margin is calculated as total minus runner-up, and that completely messed this up. Anyway, so basically it quickly figured out alliances. When I told it that this is how think about how Indian elections work, it could quickly figure out how to calculate the number of seats and all that. But some basic things such as getting vote shares and all that, like it absolutely failed in. So this is something for us to keep in mind. Another recent example, this is some personal data that I uploaded, and I asked what is the main recent trend in weight. It says the recent trend over the last 30 days shows a mean weight of NAN. I mean, sometimes I like to call ChatGPT as a good, bad data analyst, because it can do some things well, some things badly, but these kind of things can really be infuriating. I mean, how hard could it be to kind of actually just filter out the NANs? And it says, indicating there might not be 30 days of data. It's like, anyway, I didn't let it know for any further details or analysis here. I don't want to dwell too much into this. This is just a passing insight, but there's this professor called Rao Kambampati in Arizona State, one of the OGs of AI. And he has this bunch of papers on how LLMs cannot really reason and plan. This diagram on the right is from one of his papers, and I think it's quite interesting, because this is the old, some guy sitting in Nebraska thanklessly maintaining an Excel or something, that kind of a thing. But pretty much all the reason why we think LLMs are impressive is because we have domain knowledge. We have domain knowledge, and so we are able to, so when it gives the right answer, we know that it's the right answer. The problem happens that when we don't know that whether the answer is right or wrong. In that case, we have no clue whether it's actually bullshitting or whether it's actually insightful. And I found this interesting tweet which says that LLMs are fuzzy subgraph matching machines. Because of the fuzziness of the search and scale of the training set, this can give pretty impressive results at times, right? So that's the reason why we sometimes think LLMs are great and things like that. But then, I mean, I just showed you a couple of examples of what they don't do really well. Now, there's this whole debate on the internet. I mean, you'll find plenty of papers, plenty of archive papers, not really peer-reviewed on both sides on whether LLMs can plan or not. But what Kambapati, who I'm inclined to believe, says is where LLMs can plan is where sub-goal interactions can be safely ignored. Let's say something like, give me 10 ideas for my wife's 40th birthday party. That it can give you 10 ideas because those 10 ideas are not related to each other. But then when you have to generate one idea and then based on the output of that, generate another idea and so on, it can spectacularly fail. The other thing he says is like where you can have humans in the loop, which is why you have 200 different companies which are building copilots right now. Now, this is the other thing. One of the things I found while using LLMs for data analysis is that they can be a little meek. They'll be a little tentative in terms of how they are describing the steps of what needs to be done and things like that. And that's basically down to because it's the training data. Think about if the LLMs are trained on all the data in the internet, what is the data that's available for them to kind of analyze data? It's typically blog posts of data analysis, typically by learners. It's data from Kaggle, which is again largely by people who are not really professionals at analyzing data and so on. So from that perspective, you can expect that kind of an output from the LLMs as well. It's pretty much the average of this. But if you think about it, data analysis is not a sort of a, it's a iterative hypothesis-driven process where you come up with a hypothesis, analyze data, you get some insights. While you're getting that insights, you generate more hypotheses, and then and so on. It's a loop. Actually, I hope that's the next slide. This is the second time I'm talking at Fifth Elephant. First time was back in 2012 when I delivered a workshop very close to this place. It was at the CIS office, which used to be sort of across the road back then. There I had given a talk about how are humans supposed to get insights from data, and I'd used the slide, which is basically, notice this loop in terms of generate hypotheses, test the hypotheses, and while you test the hypotheses, generate more hypotheses and things like that. So that was the process of analyzing data that I'd given in terms of humans. Now think of how you can do this with LLMs as well, because LLMs, what they're good at, they're not good at planning. What they're not good at is saying that, okay, do this repeatedly and things like that. I mean, occasionally they'll do, but not all the time, right? So again, going back to the same set of papers on LLM planning, there's a thing called LLM modulo frameworks that we have found pretty useful. You can think of this as a sort of a jugalbandi between a creative hypothesis generator and a structured problem solver. So you have, because LLMs are great creative systems. They are, hallucination in my mind is a great thing because it allows you to be creative. Hallucination happens when two thoughts from different parts of your life mix in your head and you kind of get a little confused. And that's precisely how creativity happens as well. So hallucination is great. Only problem is that if you are relying on a system that hallucinates without any checks and balances to generate your output, then you can have some not so great output, right? So what this modular framework suggests is to put some kind of a framework around this. Ask the LLM to generate the plans, and get a sort of a more deterministic system to validate the plans. Now the thing is, if you have a LLM and a deterministic system, the deterministic system will need some kind of a deterministic input. And what this paper talks about is that LLMs are also great at converting their plans into deterministic inputs. I'll come to give you an example in a little bit. So you get the LLM to generate the plans, ask them to translate it in a way that a machine can understand. Your machine, which is not an LLM, is going to evaluate the plans and critiques it and gives feedback to the LLM. And then the LLM generates more plans and things like that. And we have tried this so far, at least in our limited experience in building an AI data analyst. It's a great way to build a data analyst. And we strongly believe this is a great way to build other LLM-related systems as well. So I don't know if any finance people here. So what I have here is if you think about it, you can think of the LLM as being a highly volatile stock. And the stock has a high upside and a high downside. You pair it with a put option, which is the red line here, which gives you downside protection. And so that gives you the green payoff, which is downside limited, upside unlimited, which is what you really need, right? So that's the whole framework that we are using. So going back to my 2012 framework, so this time I copy-pasted the slide rather than screenshotting because I didn't like the blue background I'd used 12 years ago. So LLM will generate the hypothesis. Hypothesis validation is done by a deterministic system. And then when you go to the feedback loop, you get the LLM to generate more hypotheses. So LLMs are being used as a creative system here in terms of generating ideas, in terms of telling what might be possible, which can include a whole lot of bullshit. So for example, if you are going to use some parameter like temperature, it's good to have set a high temperature for this, because what you want is for good creative ideas, because you have another system that's filtering out all the bullshit. And then and that's how you generate insight from data. I'll give you one example. I mean, as I told you, we are still in very early stages of building. So I'm giving you an example related to what we are building right now, which is a automated data cleaner based on an LLM. I'll start with a good example. So I gave it this data. I have some data of Bangalore rainfall over like last 45 years. Like if you follow me on Twitter, you'll see me putting up some graphs on this from time to time. So I gave it this data and said, clean it. It did great. It identified that this lat long can be separated into lat and long and separated it out here. It figured out that this index is actually, what do you call it, epoch time, and converted that into the time. It figured out that these columns don't really mean anything, and so it dropped them. Great example. If this were the only time you were to use LLMs to clean data, you would think that all analysts would be sort of out of their jobs and you would be looking for a career change right now and things like that. But then at other times, it also gave me this. In one iteration, it decided to convert the temperature into Celsius from Fahrenheit without realizing it's already in Celsius. Now, how do you get an LLM to not do this without explicitly overtraining it? It decided to clean temperature by removing extreme values that's beyond plus or minus 3 sigma, which again is not right, because there can be natural variation in temperature. So if you were to ask for what's the hottest day in Bangalore, that would go off because it had been cleaned away. One more time, it decided to normalize temperature using z-score. Now again, if you think about it, LLMs are an average of all the training data, and a lot of the training data on the internet for data analysis is for machine learning, because Kaggle again is largely machine learning. There's very little, I mean, if you look at the material on the internet for data analysis for the sake of generating insight versus data analysis for the sake of building ML models, the latter is much, much more. And normalizing data is something that you do while you're building ML models, not necessarily while you're trying to get insight from data. So it automatically does that. And then it happened yesterday. Unfortunately, I didn't save it, so I couldn't screenshot and put it in the slide. It would take index, convert it into date time, and then in the next step, convert it back into numeric. I have no clue why it did that, but it kept cycling through that through the thing. So it can do all sorts of random things. And so what you need to do to get around the hallucinations, I mean, this is again just one example. I mean, I'm not going too deep into this. You ask ChatGPT to suggest. So it says, I asked it to give it in a very structured format, saying, tell me what the cleaning method is, what column it applies on, what the code is. So what you see is that, like, and the reason you get the code is so that the reason you get the code is so that you can quickly feed it into the deterministic system, which can then implement the code and see if it's doing properly. So it does that, gives great input. Now the one problem that I think I told you a while back, that the NDA versus UPA India problem, which is that the LLM's training data is everything that's on the internet, which means that how do you make sure it only takes the latest data possible when latest data has overwritten something? I had this thing where it gave me code that was working well with NumPy 1.3 point something. But on my system, I have NumPy 2.0 point something. And the code started failing. And there was absolutely no way for me to get the right code there. So what I'll be doing on Monday is to try and rewrite the whole thing using R, which is also a language I'm much more familiar with and which is much more robust to these kind of things rather than Python. But anyway, so you ask ChatGPT to suggest, including code, and then you get an external system to validate. And to write this validator, this is where you need actual domain knowledge. And again, in terms of like, how do you figure out whether you can't use an LLM to catch another LLM? So for example, Again, I haven't screenshotted this. I asked an LLM, uh, how do you determine whether a cleaning process has gone right or wrong? It again spat the same Kaggle thing, saying to clean data, you need to remove outliers, you need to remove the number of NANs, you need to normalize the data, and a couple of other things. Which is exactly what the hypothesis generator has given. So in that sense, there's no use of using the same LLM to validate the same LLM, right? So you need some kind of a deterministic system. For example, have I put something there? No, I haven't. For example, something like make sure that the fundamental distribution of the data has not changed because of all your cleaning. Make sure that information, the loss is not significant because you have maybe removed some columns, removed some rows, and so on. Maybe you use some ML methods here to check whether the new data set makes more sense than the old data set and so on. And then you iterate. You need to tell the LLM to iterate. You need to, so that it keeps coming up with newer and newer insights. Right, so finally, to just summarize, I mean, I had no clue how I'm doing on time, so I possibly went a little quick, but that gives us more time for questions, assuming you guys have questions, that is. LLM is great at generating ideas. It's also great at taking the ideas and giving it a structure. But LLMs are an average of all the data that they've been trained on, so you need to remember that. So it can also generate some pretty poor ideas. So what you need is a deterministic system that can evaluate and bless some of these ideas. And the system needs to be iterative so that we can mimic the human analysis process. So I think, yeah, I'm done with the talk now. So I'm happy to take questions. I think I'm good on time. Thank you.
Hey, Karthik, good stuff. So on the last slide, right? So you kind of spoke about how you want a deterministic system to essentially evaluate the hypothesis that the LLM generated. Isn't that what a copilot is? I mean, you're eventually coming up with an answer and you're validating it.
No, that is what the human in the copilot, that's what the pilot in a copilot model is. If you think about it, when you work with a copilot, what happens? You ask an LLM what to do.
Yeah.
It gives you ideas. You are the deterministic system who's validating those ideas and deciding to accept or reject some of them.
Correct.
Because you have domain knowledge, you are able to accept or reject.
Okay.
A copilot is limited by the ability of the pilot to be able to be good at the task.
Right.
So as long as you are good at the task, you can do well. So because you yourself become the deterministic system. But if you are trying to build an entire system that is outside where, let's say if you want to generate thousands of hypotheses for data and test them, which is way beyond the sort of the abilities of a human data analyst. Right. There you need the LLM, the system to be both the pilot and the co-pilot. And there, one leg has to be deterministic. If both legs are stochastic, you will get some random results.
Okay, just to follow up on that, when you say a deterministic system, can you give like an example, like test cases to generate if something is working, or what do you mean by a deterministic?
Yeah, you think of it as test cases to test cases. So see, right now we've written some fairly stupid deterministic systems for the data cleaning bit. Things like, for example, is there some kind of a, if you look at the, let's say it has changed some column in the name of cleaning. Has the distribution changed?
Right.
So, for example, like in one of the trials I was looking at yesterday, like there was one of the columns was a price. It decided to eliminate outliers. Now, this is the data set which has prices of different items. So obviously, if there's an outlier there, like for example, like Zomato started selling phones on Blinkit. The price of the phone is not an outlier there. So, and if you were to replace that with median, that's a wrong thing to do. Yeah. It got quickly caught and the step was not implemented.
Got it.
So change in distribution is one thing. Or for example, sometimes it randomly decides to drop columns because it's seen as cool to do that and so on. So how do you determine whether there has been some information lost there and so on? So again, you need domain knowledge. You can use LLMs to think of ideas at a one time, but that needs to be encoded into a deterministic system, because if you have both legs stochastic, it can still result in stochastic output.
So the last question on that is that the current thought process is more that you use your domain knowledge to construct the prompts.
Yes.
Right?
Not the prompts.
You're saying that's not the right way to do it.
That's not the right way to do it.
Okay.
You use your domain knowledge to verify. Because LLM is creative. LLM is creative. You want to run it with a high temperature. You want it to
Go crazy.
Go crazy. Because you know that the negative part of the craziness you will take out. Because the positive part of the craziness is what you want here.
Right.
So in that sense, you don't want to clip its wings. You want to basically just put a downside limit on this one.
Got it. Good stuff. Thanks.
Yeah, great talk, Karthik. So one of your hypotheses was that what the data analyst is doing is really repetitive and can be done easily, right? So if we no, okay. So correct me first, then I'll continue. So is okay, maybe not repetitive in types of the questions that they're doing, but repetitive in terms of the rules of data analysis that they're applying. So rather than going to build a completely, creative stuff, isn't it more like we automate some of the simpler stuff with the LLMs? Like, or LLM, I don't even know whether LLM is the right solution. I just find that really weird. But, why don't we, if we are going to do deterministic systems to check, which means there are some rules, we're going to expert systems, knowledge systems to bake that checking system, procedural checks that we want to do. Why don't we first start with simple stuff that can be codified? What's the gap in that thinking? Why do we need to go to this giant LLM model? Why don't we have a simple classical ML model or a smaller quantized model trained just for this cleaning task? What's the gap in terms of going from there to this vision that you're going?
Okay. See, the thing is this. Again, in terms of what the data analyst's work is, I have this definition of what do you call it, a high-functioning and a low-functioning data analysis team. The function of a low-functioning data analysis team is to take questions from the business and answer them. Somebody will be like, tell me how many customers we acquired last week. You write an SQL query, get that, and answer them, and so on. Or you'll get a question saying, why did my sales drop last week? You do some analysis and get back to that. The job of a high-functioning data analysis team is to guess what questions might be asked, is to ask the questions themselves, because they're close to the data and they have
Sure.
an idea of the business, right?
But
and
if
now,
we take away the low-value questions and that system is automated, the rest of the human, because we're not removing the data analysis out of the picture, can still answer the high.
that is the copilot vision, if you think about it, which is to automate away the low quality, the low functioning data analysis kind of work. Because there, what they're saying is like, if you can prompt me well enough in terms of the answer that you want, think about a thought spot or something similar to that, we are going to be able to, we will construct the SQL queries for you, we'll extract the data, present it nicely, and give it to you. Here, what we are saying is like, can we anticipate what questions might be asked? Can we look at the data and generate the questions ourselves? And in order to generate the questions ourselves, we need to hypothesize. And that's where we need to leverage the creativity of the LLM.
Okay, I guess because the way you frame the talk, you're only using LLM. In a company like Delivery where you were, there'll be a lot of local domain knowledge, right? All of that also has to feed into, for the LLM to get to know how Delivery works or Zomato works or your organization works, right? So along with this part that you're trying to build, where would you get the domain knowledge for the company that needs to feed into it? Which the data analyst is bringing by being there in the job?
Yeah, that's a good question. It's a problem we need to solve as we build a system out. We are still in very early stages of building. Right. But if you can think of it, there is a way you can, if you are able to sort of, for example, again, a hypothesis, you can go through, maybe we will present our insights in some system where people can annotate in terms of why something happened and so on. That, or maybe you can look at existing documentation within the company and do that whole unstructured to structured data analysis to get the tribal knowledge which sits and things like that. But see, ultimately, you don't need to do 100% of the work. For example, if you were to say that yesterday my orders went down by 1%, and 90% of that can be related to the store in Indranagar. The manager who is looking at that, you can expect them to be a good business person. They'll know that if 90% of the drop happened due to the store in Indranagar, they know what's happening and why that happened. They don't need to know the entire, the system doesn't need to tell the full story.
Okay, before I ask follow-up, somebody else has a question, they can come. Yeah, come, because then we can continue the discussion. But I have some more question on the semantic layer, which seems to be missing here. Because we're focusing on the syntactic layer. We're missing on the semantic layer of what the business does and the contextual layer of where this question is being applied. The syntactic part, I understand the code generator does. But I'll catch up with later. Go ahead.
Yeah, hi Karthik, very interesting talk. This is Vikram from a startup called Revify. We do cloud operation, optimizations, and so on. One statement that you mentioned was like, do we want to use high temperature for a task like this, right?
Yep.
Wanted to question that a bit, like why? Because typically I would use high temperature when I'm trying to do more creative tasks, like generate text and so on. Why that randomization is important for a very structured task when I'm trying to do a process like data cleaning? That's question one.
Okay. Data analysis is not a structured process. I mean, this is one misconception which I want to start by clearing, saying that data analysis is a fundamentally creative process, where you need to try and come up with why something is happening, what needs to be done. Think about cleaning, for example. Like the classic way of, if you look at the average Kaggle answer on cleaning, cleaning is a procedural task, which is to say that like remove missing values, maybe drop outliers and so on. But if you think about it from the process of doing data analysis, cleaning is something that's highly intertwined with the data analysis process itself. It's as hypothesis-driven as data analysis, because you analyze some data, you look at some patterns and be like, okay, there's something in that pattern that doesn't look like right. Maybe I should go back and clean this data and things like that. So it is a creative process at the end of it. And because it's a creative process, we need to use a high temperature here.
Interesting. So you're kind of, are you mixing cleaning with finding the final insight? Because there I can see, yes.
No, it's all, there's no such thing. Cleaning is not a separate process from the finding the final insight. It's all completely integrated.
Okay, fair enough. The second question is, like when you want to build a validator, which is external, which is deterministic, you will essentially need to get role-based and also probably, rule-based.
Yes.
Instead of that, wouldn't like using some generic things and just doing prompt engineering or providing RAG and then trying to do that? I personally tried that, and that worked like without using an external validator, and it gave much better results.
You get much better results
than initially think. So I just wanted to see if there is some benchmarking or something that you did where this type of external validator works better than prompt engineering using a RAG, giving it more context before it tries to answer on cleaning jobs or whatever like data analysis jobs.
Yeah, so I mean, I fundamentally am not a fan of benchmark tables and things like that. The what do they call, the leaderboard? Is it? No, yeah, those things I'm absolutely not a fan of. But I think from this perspective, just based on anecdotes, based on all the things that we have tried, yes, some better RAGs, some better prompting can definitely help. So, for example, yeah, things like don't normalize if you explicitly say it's not going to normalize. So to a large extent. So in that sense, some of it can be solved. But then like, how do you sort of still retain the creativity? You still need to kind of give it some more freedoms and then like cut off the freedoms later. That's better than, see, think about it. Think about it from a statistical process control perspective. You have your type 1 and type 2 errors of omission and errors of commission. Now, if you were to, typical process is that if you try to increase if you try to reduce the error of omission, you'll end up increasing the error of commission, and so that's a trade-off here. So instead, if you were to have two reasonably uncorrelated systems, one generating, one testing, then the one that is generating can be sort of, you can try to reduce the errors of commission, errors of omission there, so that the other system will can cut in the opposite direction. So that's the whole point of using two separate systems, which is to keep the creativity while not letting it do random things.
All right, thanks.
Hi, so my question is around handling ambiguity. So in your example, for example, temperature could be in Celsius and could be in Fahrenheit. And I think in real world data comes with a lot of unsaid context, which real humans sort of bring into the picture. So I know you might not be there yet, but what are your thoughts on that? And I think it also relates to the question of syntax and semantics, wherein in that example, you would have seen latitude and longitude and would have figured out it's Celsius because it's India. But how does an AI data analyst really figure that out?
Yeah. How does an AI? Okay, that's a good question. I mean, you're right. Like I haven't given it too much thought in terms of how do you figure out the semantics? It again, I think it has to, in some sense, uh, think of a check, which is that like, given the, again, even the validator, somewhere you will need to use a little LLMs and stuff, because otherwise the problem is that you will have to sort of write infinite code base, right? I mean, the reason why I'm building this now, while the initial data, I had written a blog post about this in 2014, detailing this idea, but back then it was not possible because you had to hard code too many things. Now, what can happen is that, like, in some sense, one of the checkers can be that we are trying to, with this column called temperature, we are trying to do Celsius to Fahrenheit, and this is the range of the data that's there. Is that right? I mean, you can't use temperature, but like somewhere with using an LLM, you can try to, you can, in some cases, you might need to use two different levels of LLMs, I guess.
Yeah.
You
I
know,
think maybe something like a devil's advocate where
devil's advocate,
someone's
or
job is to shoot down
exactly
really crappy ideas.
so something of that sort. I mean, not a solved problem yet. We haven't got there. We're still in very early stages, but yeah, that's something we want to do.
Thank you so much, Karthik. Fascinating insights. You mentioned that the LLMs are trained just on the data that's on the internet, and that means there's not much of detail about what a specialized data analyst guy who really knows his stuff. That knowledge is not easily findable on the internet, if I understand you correctly. So how do you expect, if you bring the creativity up, that it will then suddenly still kind of guess what a real expert would have done? Or do you still have to enrich it in some way? Or do you think just by pumping up the creativity you'll get there? Or how do you think you bring this? Because the more general question, we often have that issue, those large language models are wonderful, but then as soon as you try to put them to a more specific, more specialist task where the knowledge is small, you end up with a lot of useless, of more generic answers.
Yeah. You know, you're right. I mean, like, at least to what we see now, just bumping the creativity up is going to still, like, I mean, it can still, the signal to noise ratio may not be particularly high there. We will need to enrich it in some way. I mean, that's something we have to do, like in terms of like maybe a RAG or a fine tune or something like that. I mean, that cannot be wished away. And what I was talking about, the LLMs being a average of the knowledge of the internet, is in terms of like the process, right? Like in terms of if you ask it to clean data, it'll suggest the same 5 steps every time, because that's what is largely found and things like that. So you need to prompt it better. You need to possibly fine tune it, or you need to give it better context. I mean, that cannot be wished away. But even if you like, there was somebody else who had this question. Even if you were to sort of you use a RAG or a fine tune, still, there will be some cases where you might want, where it can still hallucinate. And so you need a deterministic checker, and so you need this kind of a framework there.
Yeah, thank you. Yeah, I fully agree. You will need the deterministic first, but the question is indeed, can it come up with potentially good ideas when it's just so trained on some average?
No, you need to
Yeah.
prod it.
No,
first.
thank you.
Thank you.
Can you talk a bit about the deterministic system? Like, how are you thinking about the
It will be a procedural system. You might, I mean, while we are building the deterministic system for a specific context. So, for example, the context could be, so for example, think of the, let's say we have an insight which says that like sales are down 20% last week. You can get an LLM to, you have the LLM side of the system which you can ask, give possible reasons as to why this is there, and based on this data, give me code to test all of this. The deterministic system will probably then be some kind of a statistical system which will run all of these, see if like maybe sales were down 20%, but that's still within range. That's still within range of the volatility over the period of time or something, and it will return based on that and so on. So see, the thing is this: the LLM both has to do the creativity, and it is tasked to take this creative output and code it in some sense in terms of a deterministic prompt that can then be executed by the deterministic system.